Turns on. There we go. Ladies and gentlemen, thank you for having me here today. As you might know, I'm Ukrainian, and unfortunately, I would love to say that there are a lot of business opportunities in Ukraine right now and you should invest. But unfortunately, if you're not in military or hunting business, there are very little opportunities. That's partly the reason why I'm here today. The technology that we were developing and the industry we've been developing in Ukraine is called additive manufacturing. I'm sure you're quite aware because metal additive manufacturing actually came from Germany. But we've developed quite a successful company that was growing, that was expanding, but unfortunately, due to the current situation, we had to relocate. I'll start with the basics. I'm sure many of you might know what technology looks like, but I would like to just cover the basic. Additive manufacturing technologies use a paradigm that allows you to manufacture the material step by step. Rather than subtractive manufacturing, you add material to achieve a final shape, layer by layer, track by track, and it can broadly be divided into three general categories, depending on the material that you use. If you use powders, say metallic powder, plastic powder, you can use laser or electron beam to melt those powders together, layer by layer, achieving a final component. You can use a photosensitive photopolymeric resin, where you would use a curing station that would polymerize a resin into the final component. Or there's more traditional, more well-known technologies that use a wire, rod, or a filament that would melt it and deposit in required locations to get the final shape. Something similar to multi-pass welding technologies using rods. But this paradigm of this new technologies, it allows some new breakthroughs and some new opportunities into traditional manufacturing. Like, first of all, it's rapid prototyping. That's how the technology actually started. If we look at the sequence which usually happens in every company to bring a new product into market, it all starts with an idea, then a prototype, then prototype refinement, and then industrialization and bringing the product to the market by serial production. And at this stage, that's where additive manufacturing can excel. The process of refinement of your prototype, the process of manufacturing your prototype is much, much easier using additive technologies than subtractive technology, especially because you don't need to produce tooling to make your first prototype, and you don't waste a lot of money, a lot of time. And as a result, it gives you a reduction in manufacturing cycle and increased product turnaround. Therefore, if you increase this process, you can increase the output of new products within the specific industry. Obviously, you can also, if you move one step forward, you can reduce the cost for small batch manufacturing. Might not be a case for everybody. Mass manufacturing is the way to go, yes, but there's always a niche in the market just before we go mass scale, where tooling is too expensive to produce, let's say, 100, 200, 500 pieces. And that's where you can mass manufacture using additive technologies. One of the key things that also this technology allows is the complex of the geometry. You can make very intricate shapes and very unique shapes, and you can print them all at once in the same batch. So if you have 15 clients, or everybody wants something unique, something complex, you can print it all in once, and you can install it in your final product. And as one of the topics that were touched here today is waste, is CO2 management. This process is kind of efficient, as you would use approximately 90 to 95% of your raw material in your final product, removing the waste, because all the powder that was not used in manufacturing this product will get reused in the next cycle. And the technology is quite versatile in circumstances of fast-changing markets. I wouldn't say you could switch from making car wheels into making dental implants, but it's possible using these technologies. So the same machine, and probably almost the same material sometimes, can be used to manufacture piping systems, can be used to manufacture dental implants, or thrust chamber for a rocket engine. And obviously, if you integrate all of the things together, you can dramatically increase the efficiency of the products that you make. By integrating several components of a large assembly into one single piece, you can eliminate manufacturing stages and reduce the error during the manufacturing process, achieving very complex shapes in one piece with a very high probability of success. And recent analysis of the market actually showed that there are a lot of parts within the car structure that can benefit from using additive technologies. I have some of them on the table. I will come back to them later, but if you want to pass them around to have a look of what the technology is capable of, please feel free. Talking about ourselves, as I said, we're a Ukrainian company. We started 2017 in Dnipro. We started as a manufacturer of metal 3D printing equipment, but then after some time we realized that the biggest market is not just making and selling machines, but actually selling the service, because we have the knowledge of how to implement this technology into the manufacturing cycle. And because we make the machines, we can adapt them to the client's specific needs. Therefore, after some iterations, we had some more machine design iterations. We opened up new locations within the Ukraine, in Kiev, in Odessa, to provide these services to Ukrainian companies. And I think by the end of 2021, we had around 120 different Ukrainian high-tech companies using our services or implementing their technologies into the manufacturing process. Primarily in aerospace, where we had a few cases of automotive manufacturers as well, for manufacturing of tooling, inserts, for injection molding. But unfortunately, as you might know, 2022 war struck, and we are now relocated to Poland. And that's primarily is the reason why I'm here today, to reach out to see what's the market like in Germany, if anybody wants to cooperate. In terms of what we do, as I briefly mentioned before, we are an end-to-end solution provider. We make CAD design, adaptation of components to metal 3D printing. We do reverse engineering. For instance, we had a lot of cases when technical documentation for a specific product has been long lost, or in Soviet Union somewhere, or in the territory you can access, and you need to reproduce the products. Therefore, in these instances, we can reverse engineer any component, because we have a good internal lab, a collaboration with the educational facilities that can check the material, what the material is made of, what's the composition, and we can replicate it in full. But also we can adapt the components to be as lightweight as possible, as strong as possible, as adaptive to the specific conditions of use as possible. In terms of that, we have an internal material testing lab facility that does alloy design. So we don't just adapt the 3D model, but we can create a material specific for the task required. Where we would also verify that all the mechanical properties or the chemical properties are met according to the specification. And as I said before, we also OEM manufacturer of metal 3D printers. So we can install the full solution at your facility. We can take your hand, introduce you to metal 3D printing, to plastic 3D printing, walk you the way from the first prototype down to potentially, hopefully, serial manufacturing using additive technologies, and install that facility at your location. That's just a few examples of how the process looks like of 3D scanning. I wanted to include a bigger one, but unfortunately that was under NDA, so please see the architectural part being scanned instead of automotive. But the process here is the topology optimization or lightweighting, where we would induce loads in a finite element analysis scenario to tell what loads the part experiences during exploitation, and then the software subsequently removes the material from the locations which are not loaded. And at the end, we receive very optimized, very lightweight structure, depending on the use case. Obviously, it's not versatile as the initial big bracket there, but for the case that it's going to be used for, that's the optimal shape. In terms of manufacturing new materials and designing new materials, that we can do as well. We have an in-house atomizer that can produce metal powders to be then printed on our equipment. Equipment itself, 2 machines and supplementary equipment. I think Germany has about 5 different manufacturers, but they're not as versatile as us. The actual process, so the laser scans the 2D section of the component, melting the powder, achieving a final component. But also we are working not just with metals, but also with plastics. And one of the technologies that can allow you to go into mass-scale manufacturing with complex shapes is probably DLP technology, digital light photopolymization. So it uses photosensitive resin and LCD screen to cure the full layer of parts at the same time. Then if the platform raises by, let's say, 100 microns, then the process repeats. But this allows you to make mass-scale products. Maybe not the same cost in the long run for 100,000 pieces, but let's say 2,000, 3,000, this is going to be much cheaper. You don't need any tooling for this. And also we work with FDM Technologies. So in case you want a big prototype for the car bumper, for internal lining, we can do that as well. As I said, we have an internal facility to verify that everything that we say is true, and all the mechanical properties that we say your part is going to have, it actually has. So we had, to be fair, we had an accredited laboratory, but unfortunately now it's closed. But now we are relocated to Poland, and we are collaborating with Polish universities to re-establish those connections. And in terms of our experience in automotive, there are plenty of different materials that you can use for different parts of the car, different components, including aluminum alloys. So this is an example of a power cap that we built for a custom shop. You can see the internal inbuilt dimples, structural ribbing, and all embedded into one single piece. So traditionally it would take a very long time to make such a piece. Chevron gear with both outside and inside, very hard to machine. And also made with a very strong material called Inconel 718, traditionally used in aerospace engines. Piping systems, thick section, traditionally very hard to bend, but here you print the single piece, you don't need to weld them together. Or radiators with dual function. Let's say you want it to be both a structural load-bearing part and also a cooling system. So here, this one not only can do that, but also has a dual channel liquid cooling that are not mixable. The grills are inbuilt into the single piece, and also it's made of titanium, so it's very light and very strong. In terms of how reliable are we have over 65 articles in international journals, 2 PhDs, and probably over 30,000 of work for R&D and development of the technology. So we have quite an impact worldwide, and we'll be happy if you could support us, find us a partner, or become our partner. So in that sense, thank you very much. And I hope that you will not think of Ukraine as a country because of which you have an energy crisis, but rather a potential to find a partner in a market where there are a lot of startups and big companies like this with innovative solutions that can bring economical benefit for all the countries in the European Union. So thank you.